Today we'll do a demonstration on t-test or paired sample t-test. It's also known as t-test for dependent samples or t-test for related samples, and we'll be doing it using Excel. To give you a background about our current dataset, it was hypothesized that a certain intervention program can have or can reduce the number of aggressive acts. The intervention program is a dichotomous variable. There are only two possible variations, that is with or without the intervention, and the aggressive act is measured in terms of the number of committed acts within a sort of a 3-month period. So in here you can see our data. So this is the number of aggressive acts for a 3-month period prior to the intervention program. So it's labeled as before, meaning to say before the intervention program, and the program was carried out, and afterwards within 3 months the number of aggressive acts were again measured, and these are the measures after the intervention program. So you may consider this particular example as having a pre-test post-test design. So this is our data prior to the intervention program, and this is our data after the intervention program. So essentially we'd like to know whether or not there is a significant decrease in the number of aggressive acts after the intervention program. So to perform this, we use this particular function in Excel, data analysis. If it's not yet available in your Excel, then you have to install it. It's an add-in. The video tutorial for adding this particular function is available in my other video, so please check that out. So first, let's click data analysis. First, let's have a look at the descriptive statistics. So let's click descriptive statistics and then click OK. Now I used this a while ago, so this should be empty when you open this. So putting it into default settings. Okay, so for the input range, just highlight our data. So there are about 28 participants, and then since our first row are labels, click on labels, and for the output range, don't forget to click the box and choose a cell wherein you would like the statistical output to appear, and then click on summary statistics and click OK. So this is the result of our descriptive statistics. So this is the mean aggressive act prior to the intervention program, and this is the mean number of aggressive acts after the intervention program. And then later on we'll use other data. So this is the standard deviation for both of the groups. Okay. Now you have to remember that although these are two sets of data, both of these data come from the same participants. Like for example, one of the participants' number of aggressive acts before is 10, and after the intervention program it was reduced to 7, and that goes for the same for the other participants. Now so to perform paired samples t-test, let's click on data analysis again, and then look for t-test paired to sample for means. Now we use this when we have two sets of data that are coming from the same sample, usually in the context of a pre-test post-test design. We also use this when we have two sets of data that are coming from two separate samples, but there was matching that was done to control for a certain critical variable. Then let's click OK. So let's empty this again. I used this a while ago. Alright, so for variable 1 range, just highlight the first column of data. For variable 2 range, highlight the second column. Our hypothesized mean difference is 0. The null hypothesis suggests that there is no difference between the means, or more precisely, the mean differences between the two sets of data is 0. And then let's click on labels, because our first row are labels. And for the output range, let's choose a cell and let's place it somewhere here, and then click OK. So this is the result of your paired sample t-test. So now, assuming that you are using you're testing this using a two-tailed probability, so we have to look at this particular output. So here are the means again, and essentially what we'd like to know is whether or not this observation in terms of the differences of the means is something that happened by chance. So we're asking for the likelihood of it happening by chance. So if it's highly likely, then we might say that the differences are just a product of random chance events. But if the difference is but if the probability is very low, so it means that it's very unlikely to have happened by chance, which may be an evidence to this model that we are proposing. Now, if you look at our p-value, this is normally what we look at, you would notice that it's not your typical, it's not what you expect. Okay, so to convert this into a number, just click on number and then click on number again. Maybe we'd like to increase the decimal places into 6, maybe. Click OK. There is your probability value. Okay, so the likelihood that this happened by chance is very, very slim, considering that our alpha is 0.05. This is much lower than 0.05. Therefore, we might say that there is an evidence that there is indeed a significant difference between or this observation with regard to the differences of the means is unlikely or less likely to have happened by chance, and because of that, it gives us quite an evidence that the intervention program indeed was effective. In this case, there was a reduction of the aggressive acts. Now, since our result is significant, let's now determine the effect size. Effect size, particularly Cohen's d. And to perform that, you go to this website, Daniel Soper, statistical calculators, and choose effect size. which will bring you to this page, and it would ask these information. So mean of group 1, mean of group 2, standard deviation of group 1, standard deviation of group 2, and just click on calculate, and this is the data. Now, where did we get this information? Here. So these are the means of groups 1 and 2, of sets 1 and 2, and here are the standard deviations of the respective data sets. Okay. And our value, let's copy this. So this is our measure of effect size. So the rule again, if it's less than 0.2, it is a small effect. If it's between 0.2 and 0.8, it is a medium effect. And if it is a larger than 0.8, it's a large effect. So in this case, this is a medium effect. So there, I hope that this helps, and do check out for my other videos, and soon enough we'll make more videos demonstrating other statistical hypothesis testing techniques.